angles and their measurement. Might want to get out a highlighter if you have one. All right. So let's talk about angles and their measurement. Okay. So an angle is formed by two half rays or half lines. So here's an example of an angle formed by two half rays. The angle, right, the half rays are connected at the endpoints, which is called the vertex. One side of the angle is labeled the initial side, the other side of the angle, one half rays is labeled the initial side, the other half rays labeled the terminal side. And the size of the angle is measured by the amount of rotation from the initial side to the terminal side. Okay. And here the rotation is measured in a counterclockwise direction. Okay. And so when the rotation is measured in a counterclockwise rotation, the size of the angle is positive. If the rotation is measured in a clockwise direction, going to the right, then the size of the angle is negative. Okay. Now, if we put the same angle, right, we put an angle between two half rays in the coordinate plane with the vertex at the origin and the initial side coincides with the positive x-axis like it does over here. We call that standard position, right? That's the standard position of an angle in the coordinate plane, right? The initial side coincides with the positive x-axis. Vertex is at the origin. And then the terminal side can be anywhere in the coordinate plane. All right, the degree measure of an angle is based on the assignment of 360 degrees to the angle formed by one complete counterclockwise rotation. So here we have the angle in standard position, right? The initial side coincides with the positive x-axis, and the terminal side of the angle is also on the positive x-axis. And so the amount of rotation from the initial side to the terminal side, right, is one complete revolution. Okay? And that one complete revolution is equal to 360 degrees. If the, and it's already noted, right, if the rotation is counterclockwise, the measure will be positive. If the rotation is clockwise, right, going in the right-hand direction, right, then the measure of the angle is negative. Okay. So in this example here, right, the amount of rotation from the initial side to the terminal side is 1/4 revolution. Right, and so that's a 1/4, 360 degrees is 90 degrees. And over here, right, the rotation is in a clockwise direction from the initial side to the terminal side. That's 3/4 of a revolution in a clockwise direction. And 3/4 of 360 is 270 degrees. And so that's the angle minus 270 degrees. Okay. I'm assuming everybody in here had some form of geometry, right, or trigonometry, right, where you learned about angles in high school. Okay. When two angles in standard position have the same terminal side, we say they are coterminal, and that's very important that you understand that. Okay. Because we'll be using that fact evaluating the value of cosine, sine, tangent for various angles later on. Okay. Any two coterminal angles have degree measures that differ by an integer multiple of 360 degrees. So in the graph down below, okay, here's the angle theta, right? Right, this is the initial side. This is the terminal side. so here's theta is the angle of rotation, right, from the x-axis to the terminal side. And I can draw the angle theta plus 360 degrees by rotating the term, right, by making the amount of rotation from the initial side to the term side by going all the way around plus theta degrees. So remember, one complete revolution is 360 degrees, and then I add theta degrees, and I end up with the same terminal side. So theta plus 360 degrees have the same terminal side. And so theta and theta plus 360 are considered coterminal angles. And then likewise, if I rotate, the rotation from the initial side to the terminal side is in a clockwise direction. This angle in a clockwise direction is theta minus 360 degrees. So theta plus 360 degrees and theta minus 360 degrees are all coterminal angles. They all have the same terminal side. Okay? And that's important to understand that, because it's going to turn, as a result of them being coterminal angles, we're going to find out in the later section that the cosine of theta plus 360 and the cosine of theta minus 360 all have the same value. Okay. All right. And up above here, you can see that 90 degrees and minus 270 degrees are coterminal angles, right? Because if we drew them together, this is the angle minus 270 degrees. 90 degrees and minus 270 degrees are coterminal, right? They share the same terminal side. So 90 degrees and minus 270 degrees are coterminal angles. Okay. So in the exercise down below, right, you're given the angle 400 degrees, okay? In A, you're asked to locate the terminal side and sketch the angle. So we'll draw it in standard position, right? So you know the terminal side or the initial side, right, coincides with the positive x-axis. And so to draw the angle 400 degrees, right, that's 360 degrees plus 40 degrees, right? So we do one complete revolution. The spiral, right, indicates we're doing one complete revolution, okay? So one complete revolution is 360 degrees, and then we go in an additional 40 degrees. If 40 degrees is less than 90, and greater than 0, so this is 360 plus an additional 40. And so this is the angle 400 degrees. Okay. So draw the angle 400 degrees, right? You go full 360, right? Which is one complete revolution plus an additional 40 degrees. Okay. Any two coterminal angles have degree measures that differ by an integer multiple of 360 degrees. Okay. So, right, so we did A, locate the terminal side and sketch the angle. We did that, that's A. And B, find a coterminal angle between 0 and 360 degrees. So we can subtract 360 degrees from 400, and we get the angle 40 degrees. So the angle 40 degrees, right, which is just the rotation from the positive x-axis to the terminal side here, right, this little bit right here. This is 40 degrees, that little bit right there. 40, right, 40 degrees and 400 degrees share the same terminal side, so they're called terminal angles. Okay. C says find a coterminal angle between minus 360 degrees and 0. Okay. Well, up here it says any two coterminal angles have degree measures that differ by an integer multiple of 360 degrees. So an integer multiple of 360 could be 2 times 360, right? So we have 400 degrees minus 360 degrees minus another 360 degrees, right? Integer multiple of 360 times 2, right? And so this is equal to 40 degrees minus 360 degrees, which is equal to minus 320 degrees. So minus 320 degrees is also coterminal with 400 degrees. If we measure, we do the rotation from the positive x-axis to the terminal side in a clockwise direction, that's the angle minus 320 degrees. Okay. So 400 degrees, 40 degrees, and minus 320 degrees are coterminal angles, right? They all share the same terminal side. Any questions on that? So you flip over to page 2. We're going to talk about the radian measure, okay, of angles. And you guys have seen me wear that shirt on Mondays. It says, what is a radian? Okay. So the purpose of that is to help you learn what a radian is. Okay. So the radian measure, right? So the degree measure of an angle, okay, kind of like you think it takes a circle and it divides it into 360 slices. Right? Radian measure takes a little different approach. Okay. The radian measure of an angle theta is based on the length of an arc of a circle. Okay. So here is the circle. Here's the center, right? And no definition of circle, all the points on the circle are the same distance from the center. Okay? And so here I'm going to draw an angle, right? 2 half rays. The distance from the center to every point on the circle is the radius r, right? R is the radius. This angle formed with these two half rays, right? We say it's subtends an arc between those two half rays, okay? If this arc has length r, okay, so length of the arc is r, okay, then the angle theta formed by these two half rays is equal to 1 radian. So we have a circle of radius r, okay, and the angle formed by the two half rays subtends an arc also of length r. And so by definition, okay, the angle between those two half rays is equal to 1 radian. Okay? That's the definition. Yes, ma'am.
It's not like if the rays were in any position on the circle.
Yeah, any position. Yeah, I could have drawn them going to the left, going down, going up. As long as this arc between the two rays, half rays, is r units long, equal to the radius, then the angle is 1 radian. Okay. Well, you know there are 360 degrees in one complete revolution, okay? Using degree measure, the circumference of a circle C, you know, is equal to 2 times pi times its radius r, right? Does anybody know how to spell circumference? I wrestled with that. Circum something, right? I know I'm spelling this wrong, but it's something like that, I guess. Does anybody know how to spell circumference?
It's F-E-R.
Say that again.
F-E-R-E-N-C.
S-E-R?
No, F-E-R, like circum, F-E-R.
F-E-R.
E-N-C.
E? Something like that, right? It's one of those words. I was not a spelling major. I was a math major. Okay? That's good. So but you would think a math major would know how to spell circumference. So you know that the circumference, the distance around the circle, right? It's equal to 2 times pi times its radius. Well, 1 radian, okay, has an arc length of r, right? So we divide the circumference, the distance around the circle, by r, right, which is the length of the arc for 1 radian, and you see that 1 complete revolution has 2 pi radians. Okay. So 1 complete revolution has 360 degrees, and 1 complete revolution has 2 times pi radians, right? Where pi is equal to 3.141592654 to 9 decimal places. The only reason I know that 9 decimal places is because when I was an undergraduate, I had this calculator. The numbers were displayed in red. Whenever I hit the pi button, it came up. That's what came up to 9 decimal places. And I got it burned in my brain. So, so pi is that special number. Okay? And so the distance around the circle is 2 pi r units. And the length of the arc for 1 radian is r units. So 2 pi r divided by r means there are 2 pi radians in 1 complete revolution. Okay. Any questions on that? So it says it right here, right? The number of radians in 1 complete rotation of the initial side theta, right, equals 2 pi radians. Okay. I have it written right here, circumference. Notice that. All right. So that's the difference between radian measure and degree measure. Okay. So in calculus and other subjects, we use radian measure. We do not use degree measure. Okay. And there's a reason for that. Okay. All right. So in radian measure, okay, similar results to with degree measure. An angle formed by a counterclockwise rotation is considered positive, whereas an angle formed by a clockwise rotation is negative. Okay. And with degree measure, if you added 360 degrees to an angle, right, it was coterminal with the original angle. With radian measure, right, the addition of any integer multiple of 2 pi radians to an angle, right, measured in radians results in a coterminal angle. Okay. And conversely, any two coterminal angles measured in radians would differ by an integer multiple of 2 pi. So 2 pi radian, right, is one complete one complete revolution. So here's the angle pi over 2 radians, right? The rotation is one fourth of a rotation, and 1/4 of 2 pi is equal to pi over 2. So you have to deal with fractions when you're working with radian measure. Here the rotation is in the negative direction, right? This is 1/4 rotation in a clockwise direction. And so 1/4 of 2 pi in a clockwise direction is the angle minus pi over 2 radians. Here's the rotation, right? 1/2 rotation in the counterclockwise direction, and 1/2 of 2 pi radians is pi radians. And then, like similar in this example, we do one complete revolution and then 1/2 revolution. Okay, and so one complete revolution is 2 pi radians, and then plus 1/2 revolution is pi radians. So one complete revolution plus 1/2 revolution is 2 pi plus pi, which is the angle 3 pi radians. So pi, right, this is the terminal side for the angle pi radians, and this is the terminal side for the angle 3 pi radians. So pi and 3 pi are coterminal angles. Okay. So in the exercise down below, it says find two angles that are coterminal with 2 pi over 3 radians. Sketch the angle. Okay. So we'll draw a standard position. So here's the x-axis, here's the y-axis. The initial side coincides with the positive x-axis. Okay. Now, pi is 1/2 revolution. And so 2 pi over 3 is 2/3 times pi. Okay. So 2/3 times pi, right? This is 1/2 pi, and this is 1 pi. So 2/3 pi is going to be greater than this angle, right? Because 2/3 is greater than 1/2, but it's less than 1. So 2/3 pi, angle 2/3 pi, is going to be greater than the angle 1/2, but less than pi radians. And so the angle 2 pi over 3 is going to look something like that. Angles in radian measure. That are coterminal differ by an integer multiple of 2 pi, right? So one way to find a coterminal angle for 2 pi over 3 is to add 2 pi to it. And that angle is coterminal with 2 pi over 3. Okay. Now you got to work with fractions if you're dealing with radians. 2 pi is the same as 6 pi over 3, right? The common denominator in that sum is 3, right? 6 divided by 3 is 2. So this is just equal to 2 pi. And now 2 pi plus 6 pi is 8 pi. So the angle 8 pi over 3, right, is coterminal with 2 pi over 3. And so how we get the angle 8 pi over 3, I would draw it on here, but things get too messy, is 2 pi is 1 full revolution, and then we go 2 pi over 3 radians. Right? We go 1 full revolution, which is 2 pi radians, and then we go 2 pi over 3 more radians after that, and we end up with the same terminal sizes over here. Okay. Another way to find a coterminal angle for 2 pi over 3 is to subtract 2 pi radians. So we have 2 pi over 3 minus 6 pi over 3, which is equal to minus 4 pi over 3. So that angle minus 4 pi over 3, I can draw on my graph over here, is when you do the rotation from the initial side to the terminal side in clockwise direction. You get the angle minus 4 pi over 3. So 8 pi over 3 and minus 4 pi over 3 are all coterminal angles with 2 pi over 3. Okay. Now, since 2 pi radians is equal to 1 revolution, and 360 degrees is equal to 1 revolution, right? 1 complete trip around the circle. We can convert from radians to degrees and degrees to radians. Okay. Given an angle on one measure, we can convert it to the other measure. Okay. So, equating, since 2 pi radians equal 1 revolution, 360 degrees equals 1 revolution, that means 2 pi radians is equal to 360 degrees. So that's, we have these equations right here. 360 degrees equals 2 pi radians. If I divide both sides of the equality by 2, I get 180 degrees is equal to pi radians. And then if I divide both sides of this equation by 180, I get 1 degree is equal to pi over 80 radians. And if I divide both sides of this equation by pi and switch the two sides, I get 1 radian is equal to 180 degrees divided by pi. And so I can use those equations, okay, to convert an angle from degrees to radians, and another angle from radians to degrees. Okay. But let's do that on Friday. Okay, so we'll pause right here. Okay. I'll see you Friday.